So Parag, maybe while we wait, why don't we do some quick introductions for ourselves just so folks know who we are, and then, by the time that's done, we can probably be ready to kick things off a little bit more formally. I'll start. I'm going to probably hide myself and let Viraj and Kenton do most of the talking here, but I'm Pete DeJoy. I work on product here at Astronomer. I've been here for a while and have done a bunch of different flavors of these kinds of webinars through the years, either for Astronomer or for other kind of OSS data companies and tools. But really excited to be doing these on a more regular cadence going forward. It's a lot of fun to do this kind of thing with folks in the community. So I'll be in the chat moderating and kind of hidden behind the scenes. So feel free to ask questions there, and I'll make sure that they're surfaced to Kenton and Viraj, the real superstars.
Kenton, you're up next.
Yeah, so I'm Kenton Danis. I'm a field engineer at Astronomer. So my background is in data engineering consulting and helping companies adopt Airflow. So really excited to do this first webinar on DAG writing best practices.
Awesome. And I'm Viraj Parak. I'm our field CTO. I kind of help our customers adopt Airflow in whatever sort of environments and challenges they're running into. And just like these two, really excited to make these a common part of what we do here at Astronomer. We've done kind of flavors of them in a one-off way through the years and so on, but kind of going to be officially kicking off a regular webinar with kind of more scheduling details to come. And if there's topics that you want, definitely drop them in the chat, and we can kind of add those to the schedule as we go along here.
Wonderful. So thanks for the intros, guys. I'm going to step off here. I'll be in the chat. Viraj, I'll let you take it away.
Awesome. So first question in the chat I'm going to address is, yes, this is going to be recorded, and we'll kind of distribute that out afterwards. But, with that being said, first off, really want to thank everyone for making the time of their day, taking time out of their days to attend. We're really excited about the number of people we have attending here. I think I counted that we had over 200 people sign up on 40 different countries. So that's also a really cool stat. And yeah, just really excited to keep doing these regularly and helping build the community and sharing best practices with everyone. So with that said, I'd love to introduce Kenton from our team. Kenton, I would love if you could introduce yourself as well as talk about the topic that we're going to dive into, and we'll just go from there.
Yeah, definitely. So I'll echo Viraj. Thanks everybody for joining. We're really excited to have everybody here. So I'm a field engineer at Astronomer. I work mostly on the Airflow side, so helping companies adopt and scale Airflow in their companies. I did this pre-Astronomer and have been here for a few months, and I'm really excited about the work we're doing. And I'm, sort of following that, really excited to talk today about DAG writing best practices. We're going to go through some slides kind of with some high-level best practices and talk through those, and then we'll go through some examples with some code, really with the idea of again, we know Airflow is a really popular tool, and it can be kind of difficult to know, off the bat, like kind of the best way to do things. So we want to make sure that everybody is set up for success. So we'll be talking about things that a lot of these are, from mistakes that I have made myself or others at Astronomer have. And so we come with a lot of experience in DAG writing that we're just really excited to share with the community. So yeah, feel free to throw questions in the chat at any time, and Pete will be watching that and helping answer. And then we'll definitely leave some time at the end for kind of live Q&A as well. Awesome. With that, I am going to hopefully share my screen. You should be able to see that now.
Yep.
Myself. Okay.
It's always the most nerve-wracking part of all of the COVID stuff is if I hit share screen, are people going to see it, or am I going to be talking to myself? So,
I swear I practiced this and I still don't trust it. Like it's a new thing every time. So yeah, like I said, I'm going to get started with some slides here and kind of talking through the high-level concepts in terms of DAG writing best practices. Before I jump into the best practices themselves, I'm going to go over just a tiny bit of background on Airflow in case anybody here is really new to the tool itself. We won't dive into a lot of depth, so we'll save that for a topic for a future webinar, but just to kind of help orient everybody. we'll get started here. So Airflow, if you're not aware, was originally developed at Airbnb. It's since been open sourced and is now a top-level Apache Software Foundation project. Airflow has a really robust and active community, and it's very widely adopted, which is part of what makes it such a great open source tool. And of course, at Astronomer, we're heavily invested in open source Airflow, so we truly believe it's the de facto standard for data orchestration. And then I'll cover briefly what is a DAG. So this is obviously really important for our topic today. And within Airflow, a DAG is kind of your most high-level concept. DAGs are simply your data pipelines. So it stands for Directed Acyclic Graph, where each node in that graph is a task and each edge in that graph is a dependency. The most important rules for your DAG are that the tasks flow in one direction and have no loops, hence the directed acyclic. So this is an example of something that would be valid. Simple couple tasks with dependencies. On the other hand, this example on the right is something that would be invalid because of the loop between T1 and T4. This could create an infinite loop in your code, so that's obviously bad. Sort of best practice, I guess the first thing would be to make DAGs that are actually valid. So with that, we'll dive into sort of high-level best practices here. And the first I want to cover is item potency. So this concept is not actually specific to Airflow or Airflow DAGs, but rather applies to any data pipeline. It's a really important concept in data engineering in general. And that's why we're including it sort of up front here. You'll notice as we talk through some of the other high-level concepts through the example DAGs that a lot of them sort of exist in part to help support this one. So item potency is the concept where an operation can be applied multiple times without changing the result. A really common example that everyone's familiar with is a crosswalk button. As much as sometimes we would all like this not to be the case, you can push that button as many times as you want, and it's not going to change the end result. With a DAG, this translates to if you execute the same DAG run multiple times, you should generate the same result. Applying this concept will help make recovery from any failures in your DAG easier and also help ensure that data loss is prevented. The next concept is a big one for us here at Astronomer. Airflow was designed to be an orchestrator and not an execution framework. So we believe that users will be most successful if they use the tool this way. Now, if you've been using Airflow already, you know that everything is written in Python, and this is one of the core sort of pieces of Airflow. And that means you have the power of Python available to you in your DAGs. We're not trying to undersell this benefit. It's hugely impactful in making Airflow the highly dynamic and extensible tool that it is. However, keeping these concepts in mind in practice will help ensure that your pipelines run smoothly and efficiently. So kind of at a more practical level, this means do use Airflow to orchestrate jobs with other tools. We'll talk about this more. Again, Airflow was designed to work this way. There are many provider packages out there. That's part of what makes Airflow such a great tool. And you'll have the best time if you make use of those. Sort of following that, do offload heavy processing to other execution frameworks like Spark. Again, Airflow is meant to be an orchestrator, and so any sort of heavy lifting with your data, you're going to want to do external to Airflow. One option for doing that is using something like an ELT framework, if possible. There are a lot of tools out there now that give you access to compute like in your data warehouse, like Snowflake or dbt, things like that, that make implementing in such a way easier. That's a really great way to still leverage Airflow, but use it in this way. If you do have to use Airflow for any sort of processing, definitely do use intermediary data storage. Do not attempt to pass, huge data frames back and forth between tasks using XCOM. You're going to have a bad time. Ask me later how I know that one. That is something that I have tried myself when I didn't know any better. It was not a pretty end result.
It's almost like a coming of age thing with Airflow. Like you have to break everything with XCOM at least once before you can say that you've used Airflow before.
Yes, exactly. And so all of that to kind of culminate in don't pull large data sets into a task and process them with pandas. I say it's tempting. We know, again, I've done it. It can oftentimes seem like the path of least resistance forward, but it's not going to set you up for success in the long term. So, and I like to include this slide just to kind of hammer home the power of using Airflow as an orchestrator. So again, if you make use of Airflow's many provider packages, you can have a one-stop shop for orchestration of a really complicated pipeline with many different tools like shown here. And this is exactly what Airflow was designed for, and you can do this with relatively little code. So obviously you have a huge amount of power and flexibility in this, and really kind of taking the time to learn about how to use Airflow with these external tools and set that up in the beginning will make your pipelines really powerful in the long term. So next concept here is incremental record filtering. So this means if you have like an ETL or ELT type pipeline, to break your pipelines into incremental extracts and loads. This means you're processing smaller chunks of data in each DAG run. So for example, if you have a DAG that's running daily, you might use it to process, each run would process data for like that day or the previous day, something like that. There are a couple of common ways to accomplish this, and probably the best, if it's available to you, is using a last modified date. So in this example, here on the right, you can see in my dummy data, I have an updated date, and that's how I've defined these 3 DAG runs. If that's not available to you, sequence IDs are another common way of doing this. But essentially what you want to avoid is the scenario on the left, where you're processing all of your records at once every time. Not only is this harder to make fault tolerant and recover if there's any failure, you can imagine that if you have a scenario where your data is growing and growing and growing over time, this is going to get less and less efficient, less and less scalable.
Hey, Kenton, quick question for you.
Yeah.
Does this one relate to idempotency at all? Like, is this something I can do to help with the idempotency factor?
Yeah, absolutely. I mean, you can imagine where if your data, if you've implemented something without incremental record filtering and you are processing all of your data every time, but your data is changing all of the time, you're not going to get the same result if you run it. Similarly, if you try and rerun like a past DAG run, but now your data has changed, if you process all of it, you're going to get something different. So yes, absolutely related. Great question. So my next concept is make use of template fields, Airflow variables, and macros. This is pretty low-hanging fruit in terms of it's something that's really easy to implement, but it can make a huge difference in the sustainability of your DAGs. So Airflow's built-in variables and macros are pretty extensive, and using them not only helps with readability, but with idempotency, we've talked about any situations where you have to rerun portions of your DAGs, how maintainable they are. We'll talk about this more in detail later. But again, using them or making your fields templatable if you need a variable that isn't a built-in Airflow variable or macro, this will allow them to be set dynamically using environment variables and make use of Airflow's Jinja templating. So, super useful there. Something that's not always super apparent to people if you're newer to Airflow, but again, makes a big difference. This is another concept that's pretty easy to implement and will make your life a lot easier. Don't put top-level code in your DAG file. This is also something that I have done myself and again, didn't have a good time with. It can be really easy to define your DAGs that way because it sort of doesn't require any external work, but it's not really best practice. For Sort of the biggest technical reason behind that is that top-level code gets run on every schedule or heartbeat. So having lots of it can cause performance issues. But on the less technical side, it also makes your DAGs way less readable. It makes them harder to maintain and update and harder to debug. So we recommend treating your DAG kind of like a config file and leaving the heavy lifting code-wise to hooks or operators or external scripts if you need them. So at Astronomer, we promote a project structure that allows for easy organization of scripts and things like that that your DAGs can access. So that's what I'm showing here in this snippet from my code editor on the right with the Explorer. This is obviously highly customizable, but we recommend that everybody create a project structure like this and stick to it. I'll also note here that you can always make use of the Airflow ignore file, which is something I know a lot of folks newer to Airflow haven't heard of, but it works very similarly to like a git ignore would, and will tell Airflow to ignore certain files. So you have that in your tool as a tool in your toolbox as well when organizing your project.
Hey, Kenton, could you just kind of question the chat here? Like, could you go over what you mean by top level code for someone who's new to Airflow? Like, what do you mean by keeping code out of the top level?
Yeah, absolutely. So this will be a little clearer when I go through the examples that highlight this. But basically what that means is if you have like a Python function that you're calling or a SQL script that you're calling or something that you're like code that your operators are utilizing, store that code elsewhere, not in the DAG file itself. So top level code is anything that's essentially not your DAG and the definition of it and your tasks. So that you want to include elsewhere. And again, that's, I think, easier to highlight than it is to talk through. So yeah, I'll kind of punt that a little bit and we'll go through some examples.
Perfect.
Yeah. Awesome. So finally, we tried to touch on kind of the broadest best practices that often give people trouble when working with Airflow in what I've covered so far, but there are many others as well. Listed a few here that we think are worth mentioning. So first is definitely use retries, and when you are, set them at the DAG level. You can always overwrite for specific tasks where needed, but again, this just helps with kind of readability and consistency. I've touched on this already, but use a consistent file structure. Kind of matters less what that is, but implementing something like this will help your team of data engineers work better and more efficiently together. Use a static start date. So Airflow will allow you to put a dynamic start date in your DAGs. It's not immediately clear to me why you would want to do that, but I don't recommend it. It's confusing and can cause sort of some funkiness on the back end in the metadata database. So definitely don't recommend doing that unless there's a very specific use case for it. Choose a consistent method when setting your task dependencies. So this is kind of a specific example, but it sort of goes for a lot of things where lots of methods in Airflow, there's, you have multiple different ways that you can implement something, but choosing one consistent method will, again, mostly help like with the readability of your DAGs, and also when you have multiple team members working on the same DAG or same set of DAGs, help them work together better. And finally, if you're going to change the start date of your DAG, change the name as well, so you have that separate record. Awesome. So from here, I'm going to pop over to some example DAGs and kind of walk through the code to highlight some of these concepts. I have a couple of scenarios that I'll go through and each kind of highlight a use case, and then we'll talk about show an example DAG that's like a bad practices way of accomplishing that use case, and then one that's better. So first, I'm going to hop into Airflow here so I can show this first one. So for my first scenario, our use case is we need to execute multiple queries. So let's say we're grabbing COVID case data from a database, and each query gets data for a different state. And then those queries are going to be parameterized. They're going to utilize today's date and yesterday's date. And then at the end, we're going to send an email on completion. So graphically, the DAG looks something like this. So again, I have a separate task for each one. And then diving into the code for this DAG, the way I've implemented this here is I'm setting some variables up front that are going to be used by my DAG. I'm setting my default arguments. I'm instantiating that DAG here. And then I have a couple of different Postgres operators, one for each of those states that you saw. I've included all of the SQL code within the operator and then parameterized it. So I have the same thing repeated a couple times. And then I have my email operator, and then I define my task dependencies. So you can probably see right away that there are a couple things wrong with this. First, all of my top-level code is not only in my DAG file, it's also in my instantiation of the operators. So when I say top-level code, this is exactly what I mean, where this is my SQL query that's getting run. So this would be considered top-level code. It's not something that's it's being used by my DAG, but it's not related to the DAG definition itself, or the task definition itself. So having this in my DAG file in this way is not only inefficient from from a executing this code kind of standpoint, you can imagine it's also incredibly hard to maintain, and I'm sure you can see it's pretty hard to read just as you go through this. Again, you'll notice I've repeated the same query multiple times for each task, so the only difference in these is the state that I define is different for each one. So this is really terrible from a maintainability standpoint. If I needed to change this query, I'd have to do it in 3 different places. If I wanted to add a query for another state or even take one away, I'd have to either copy and paste the whole thing or take out an entire operator. Imagine that's just not very efficient. The next bad practice in here is how I've parameterized the queries with these dates. So I am passing them in rather than hard coding, which is good. So that's this today and this yesterday. But you'll notice up here, I'm defining these dates by calling a datetime function, or 2 datetime functions. In general, you don't want to be making function calls in your DAG outside of your tasks. So that's kind of a separate best practice. In general, this is not great. But mainly, this is also not idempotent. So if I had a failure in this DAG, say it was running daily, and I had a failure over the weekend, and so I needed to rerun the queries for Saturday. But I didn't realize this until Monday because I'm not monitoring my DAGs over the weekend. I have no way of doing that in this case. If I rerun this DAG on Monday, it's going to pull today's date, no matter which DAG run I run this for. So again, I have no way of recovering in that case. I'm going to get a different result every time I run it, assuming it's for a different day. And then finally, as a bonus bad practice here, this is kind of a goofy one, but you'll notice I've set my task dependencies using, I think, most of the methods that are available to me in this case. It obviously works. You saw the graph view. It is accomplishing what I want it to accomplish, but you can see it's confusing. It's kind of difficult to read. If I needed to update this, it wouldn't be entirely clear to me how to go about doing that. So that's not great there. So let's look at a better example. I'm going to pop back to Airflow just because I want to highlight here when I go through this good example that if I go to the graph view, you'll notice this one is the same. So these 2 DAGs are functionally equivalent. They're accomplishing the same thing. So again, we're just kind of highlighting design here in terms of best practices. So hopping back over to the code for that one. You can see right away that this is way simpler and easier to read. Instead of copying and pasting each operator, I am defining my states that I want to query for in a list up here. And then I am looping through them to dynamically create an operator for each. This automatically makes it way easier to update. If I wanted to take one away or put in a new one, I can do that really simply right there. I'm still parameterizing the query using the state. So that's going to make that much easier to maintain. And as kind of a bonus, I've added a task group, which is a feature in Airflow 2.0 to keep those a little more organized.
Hey, Kenton, quick question for you here. So it looks like by kind of referring to those SQL queries in the files instead of in the code themselves, I can have people change the SQL code without having to touch the DAG files themselves, right? So like my data analysts who don't know Python could affect my DAGs without needing to learn Python along the way.
Yeah, absolutely. So that's the next kind of big change here that you notice is that there's no SQL code in this DAG file. Instead, for my SQL, I'm referencing this COVID state query SQL file. The only change I have to make in my DAG to make that work is add this template search path, which is just going to tell Airflow that it needs to look in a folder outside of the DAGs folder for a script that it's referencing. But then that's available to my DAG there. You said I've included it here. And so you can see this is just a SQL file. So exactly as Viraj said, this would now be available to, if I had analysts working on this, they could come here and update it as needed without needing to know any Python or touch the DAG at all. Another big benefit to this, obviously, if I had to update this, I only have to do it once in one place, which eliminates all of the, you can imagine in this case, I only have 3 states. If I had 50, trying to update 50 SQL queries and make sure they're all right is probably not going to go well. Here it's all just one. So again, I've parameterized it by the dates, or the states, excuse me. So you can see that's a big benefit there. The other major change that I've made in this DAG is using Airflow variables to parameterize the dates. So you can see now I'm using this yesterday DS no dash and this DS no dash. Those are both built-in Airflow variables. When I run, they will be pulling dates that are relative to the DAG execution date. So this is now idempotent. If I reran the one for Saturday, it would be pulling Saturday for this date and Friday for this date. And then finally, again, as my kind of bonus best practice, in this case, I've defined my dependencies in 1 line instead of 4. The task group makes that even easier because I can reference all of those tasks together in sort of one thing. But that's obviously much easier to read.
I was just going to say, this is so much easier to read than the other one. I know I've seen both the examples before, but even as you're presenting them, like, oh, wow, like I actually know what's going on here in one screen versus the other one was scrolling up and down to read the SQL as well as the DAG itself.
Yep. Yeah, huge difference. You can imagine if you have a team of data engineers or even your team of analysts trying to work on something like this, that going through that first example is just kind of ripe for errors because it's just a lot to read through and manage, despite being inefficient from an Airflow processing standpoint. So again, you're getting the exact same resulting DAG here, but this is going to be a much smoother time for you. Awesome. So for our next example, our use case here is a basic kind of ETL use case. And I've chosen this one to highlight. So where our last one was kind of talking about DAG design, this one is going to be more about using Airflow as an orchestrator instead of a processing framework. So our use case here is we need to refresh a materialized view in Postgres and then query from that view, do some transformations on that data, and then load that data into new tables. We're going to pretend that the data is decently big in size, so like measured in gigabytes. So it's not like crazy social media data or anything, but relatively large. So starting with our bad example, when I go through this, I've defined a Python function here. It's going to refresh my materialized view using this Postgres hook to make the connection, and then I'm creating a cursor and executing this query. I'm then reading the data into a pandas data frame, doing some transformations on that data, so just pivots in this case. And then I'm using pandas again to SQL to load that data back into new tables. Couple of really bad things going on here in this DAG. The first is, remember again, we talked about Airflow is designed to be an orchestrator. In this example, we're using it for exactly the opposite. We're pulling all of the data into memory and processing it right here using pandas. So if this actually does run, and I say if because that would probably depend on your Airflow setup and what resources you've given it and actually how big that data is. It's still a highly inefficient way of accomplishing this use case. If you've ever tried to use SQL to load a relatively big data frame into a table, you'll know that it's incredibly slow. Ask me again how I know that. I've done this myself. It didn't go well. And this would obviously break very quickly if your data scaled up, right? So even if you get it working kind of right now, it's very fragile as defined here. The other really bad thing about this DAG is you'll notice that I only have one task. So even though this task is doing multiple steps in an ETL process, this is really bad for readability. It makes debugging really difficult. And probably most importantly, it severely limits my options in terms of recovering from failure. I'm also not making any use of more sort of use case specific hooks and operators that are available to me. So you'll notice like I'm refreshing and materialized view in Postgres. There is a Postgres operator. I'm not using it here. This is a best practice that I haven't really touched on yet. So if an Airflow hook or operator exists for the use case that you're doing, definitely use it. That's what they're designed for. They're there to make your life easier, to make sure that you don't have to write as much code. They're often heavily tested. They have built-in error handling. Like all of that stuff is going to make your life a lot easier, even though, they're all written in Python as well. And in most cases, built off of some sort of API. So in any case, you certainly could just write the Python to do it yourself. But you're sort of missing out on a big benefit of Airflow and probably making your DAGs a lot harder to maintain and work with. So again, if a hook or operator exists, definitely use it. If you do have to make tweaks to one, like it doesn't do quite exactly what you want to do, what you need it to do, highly recommend creating a custom hook or operator and importing that as an external plugin. That, again, sort of accomplishes a couple of different best practice use cases. Again, it would be avoiding like top-level code in your DAG file. And doing so also, like if you're using the operator once, you're probably going to have to use it multiple times. So if you're just defining it in a Python function in your DAG file, that's not going to be helpful to you if you have to reuse it.
And quick spoiler alert is that we do have a webinar coming in on writing custom hooks and operators and packaging them as providers in the coming couple of weeks. So be on the lookout for that.
Yeah, awesome. So looking at a better example for this use case, hop over to this good example DAG here. So first thing you'll notice in this DAG is we have 3 tasks. So one is going to be this Postgres operator that's going to refresh our materialized view, and then we have separate downstream processing tasks. So already better there. Importantly, here we have offloaded the data processing to an external framework. So in this case, I'm making use of the Airflow Databricks provider package. You can see I've imported that here. And then using built-in Databricks operators to offload that processing to Spark. Now, there are obviously many ways you can do this. You don't have to use Databricks, certainly. There are other processing frameworks, and you could use different associated operators, or you could possibly even arrange this into like an ELT pipeline, if that would work for your use case. So the main point here is we're not using pandas. Again, we're using these operators. They're built in. You'll notice I mentioned before, like one of the great things about all of the provider packages is that you can do that without a lot of code. Really all I'm doing, other than instantiating the operators themselves, is defining some things up here that I pass into my clusters. So very little that I have to actually maintain here. And then all of the actual processing power and heavy lifting is happening in a tool that's designed for it. Airflow is just orchestrating.
So question from the chat that I think we should talk about here, Kenton, is can we use the Kubernetes pod operator to do some of that processing? Would love to know your opinion on that, and I can kind of give what I've seen as well right after.
Yeah, definitely. So I would say, so the Kubernetes pod operator would allow you to, run each of your tasks in their own Kubernetes pod. So it does give you more processing power available to you, as opposed to, if you're running Airflow just on like an EC2 instance or something. The thing I'd say is doing that ensures that if you do have some sort of memory failure or something and your pod crashes, that you're not impacting your actual core Airflow setup. So I think that's a better option. But it doesn't necessarily, you can then pass in a framework to that pod to allow that pod to take up more memory and things like that. So that's, one workaround, but Kubernetes in itself is not a processing framework. So I would say if you're dealing with data that's actually large, using something like Spark or, again, like a dbt or like a Snowflake that are designed to kind of optimize around that data processing is still going to be a better and more scalable solution than using the Kubernetes QPod operator. Another reason being that, like, if your data is going to change significantly in size, maybe you've set the resources for that pod, and then all of a sudden you're bumping up against those because your data has gotten bigger, and just issues like that you might not run into if you're using a different framework. Yeah,
I think that's exactly what I've seen too, where you said it really well. Kubernetes isn't necessarily a processing framework out of the box. For who was asking, it's great for those dependencies. But if you have a Spark cluster available and you're doing heavy data processing, you can use that Spark cluster. You should use the tools at your disposal.
Yeah, great question. So again, I'll highlight here. This DAG is obviously going to be potentially more work to set up initially. I mean, obviously, if you're using an external processing framework, you have to configure that. On the other side, I've got more tasks, just more setup involved in this DAG. And I think because of that, the sort of pandas option can often seem like low-hanging fruit, especially if your data isn't big enough that it's like immediately not going to work. But again, going this route will just set you up for success in the long term and ensure that your workflows are going to scale with you without running into a ton of issues every time your data gets bigger. Awesome. So that was all I had to show from code standpoint. So happy to kind of open it up to Q&A and answer any other questions.
Awesome. So I'm going to feed some questions to you from the chat, Kenton. I don't know if you can see them when you're sharing your screen. But I think first one that I think was asked a little while ago is, can you talk about again why you shouldn't use the dynamic start date for your tasks? You mentioned that as one of your best practices, but why should I use a static start date instead of a dynamic start date?
Yeah, I think so. The biggest reason is that it's just really confusing. And I think the behavior can be a little funky. So if you have a dynamic start date for your entire DAG, you would be creating multiple records in the backend database. So that can just cause weirdness. I guess that's separate. I'm not sure if the question was more about like you can actually give your tasks different start dates. I just learned this recently and had no idea that that was even possible, but I guess it is. But again, not really best practice in the sense that it's sort of just confusing from a user standpoint. I think you wouldn't necessarily be able to kind of figure out when different tasks were running or why. So again, like that, it is available to you. So if there is a very specific use case where you need something like that to happen, then I suppose you could use it. But more just, yeah, from a best practice standpoint, it's best if you have sort of your DAG start at a static time. And then again, if you are going to change the start date, change the name of your DAG so that you're creating like a clean record in that metadata database and building off of that.
It sounds like, one thing you should always be planning for when you're writing your DAGs is when someone needs to rerun them. Because the first time through, it probably won't make that much of a difference. But it sounds like you always need to keep in your mind, like, hey, what if someone's going to need to rerun 30 DAG runs of this run or 30 instances of this run? Is that kind of a good way to look at it, Kenton? Like, always keep in mind someone rerunning the DAGs that you've written?
Yeah, absolutely. Definitely, in terms of planning for potential failures. And again, that item potency concept, where you want to be set up so that you know what's going to happen when you run or rerun your DAG, and that the next person who comes along, if they have to do the same thing, is going to get the same result. And, changing the start date for your DAG and your tasks is going to sort of throw a wrench into that potentially.
Gotcha. That makes a ton of sense.
Yeah.
Let's see, next question here. So can you talk a little bit about some of the ways that you'll be able to essentially, like, when you don't know some part of your DAG, how it's going to run, and you need to make a database call before or after that? The question as I'm reading it, doing a bad job of transcribing, is what are some of the best practices if you don't know the way your tasks are going to run before the DAG runs? Is that even something you should be doing in Airflow if you don't know what your DAG is going to look like on runtime?
So is the question like if you're dynamically generating the tasks?
Yeah. How can you handle that dynamic task generation? What are some of the ways you can do that?
Yeah, so there are a couple of ways of doing that, and I'll sort of shameless self-plug, like we have, or not self, but astronomer plug. We have a guide for dynamically generating like DAGs and the tasks within them, so that could be a helpful starting place. In terms of best practices, I think the same things apply. Like if you're going to be dynamically creating your DAGs, and you saw sort of a little bit of an example of that in my first DAG, where I'm looping through a set of tasks. So in that case, I'm defining what it is up front. So it's not like I don't know what it's going to be, but it's still looping through dynamically like that. So I think the same things apply where, in that case, like making sure that your top level code is somewhere else. All of those things, like especially in that case, I would think like setting, as many of your parameters for your DAG at the DAG level first. And then if you need to have logic to sort of overwrite those for a specific task, you can, but definitely the more of that you define sort of in the DAG first, it's just going to be a lot cleaner, and you'll sort of have a lot more control and know what to expect more than like if you're kind of defining things with every task as they come up. Those are sort of the things that come top to mind. I'm not sure if that answers the question.
I think that hit the nail on the head there. There's just so many things you have to plan for, is like kind of know what you know and then fill in from there. Another question that I think we've gotten a lot recently, especially with the launch of Airflow 2.0, is, can you talk about sub-DAGs and task groups and kind of how the two of them relate to each other?
Yeah, yeah, definitely. So sub-DAGs are kind of this concept where you have a DAG within a DAG, obviously. So they are still available in Airflow 2.0. They will be deprecated at some point, and we would highly recommend as a best practice to not use sub-DAGs if at all possible. Partly because the way that they are executed within Airflow is kind of funky, and it can cause deadlocking and other problems like that. Someone just said in the chat they are a nightmare. I think that's absolutely correct. Mm-hmm. They're really hard to maintain. It's really hard to run them. As a sort of alternative in Airflow 2.0, I'm going to share again for a second. Airflow 2.0 has this concept called task groups, which is purely a sort of logical UI construct. So it doesn't change the execution of your DAG in any way, but it gives you a way of grouping, like logically grouping tasks together. So in this example, you can see I have this task group here, and if I expand it, it's got 3 parallel tasks within it. I didn't point this out too much, but in the code, this is literally like 1 line of code to implement this. So that's a really good alternative to sub-DAGs. If you have, obviously in this case, it's there's only 3 of them. This isn't that complicated, but you can imagine if I had like hundreds of tasks in my DAG, this is a really great way of organizing them and grouping them together so that you can kind of manage them more easily and also see what's going on more easily. So with 2.0, we definitely recommend making use of task groups and moving away from sub-DAGs.
Then in the follow-up that we'll send out with the materials and all of that, we'll make sure to include some steps on how you can get started with sub-DAGs to just test them out. That way you can kind of see firsthand how easy they are to use.
Task groups, yeah.
Another question here, and I think this might be its own webinar topic, but I wanted to get your take on it as well, Kenton, is are there any best practices for testing DAGs? Or is that a deep rabbit hole that would require its own webinar to talk about?
Yeah, I mean, I think you could certainly have an entire webinar on testing DAGs. And my very short answer is yes, I think there are best practices. That can, one thing we talk a lot about at Astronomer is integrating Airflow with your CI/CD pipelines. That's one way that, not only automates your deployment of DAGs and stuff to code, but allows you an easy way to automate testing of them and things. Yeah, Faraj, I don't know if you have anything to add. Again, I think that's like absolutely a big topic that I think is really, really important and would definitely deserve its own webinar. But I think in general, like testing of Airflow DAGs, especially like automated testing, is something that we would, highly recommend doing.
Yeah, totally. I think it really depends on what you're looking to test for. Are you trying to make sure that your Python packages all work together? Are you trying to make sure that the data result you are getting makes sense? I think you need to figure out what you want to test for, and based on that, you can come up with a testing strategy. Definitely think we can do our own webinar just on that because it is a pretty complicated topic. Cool. Let me look through this chat here. Alan and Mark from Astronomer have done a great job of answering the questions as they've been coming in. So I'm looking for questions that haven't been answered yet because it looks like these guys are working overtime on that. Custom schedule. Does Airflow 2 have support for custom schedulers?
When you say custom schedulers, does that mean like schedules for the DAG, or like when you say scheduler, I think of the like the Airflow scheduler as the core component of Airflow.
Yeah.
But
let's say schedules for the DAGs. I think that's what the question meant. Yep.
Yeah. So in terms of custom schedules, so there, as far as I'm aware, there weren't any updates with Airflow 2.0 for how DAGs can be scheduled. So you still have, there's some built-in templated options, and then you can obviously pass in like a cron job. I will add that that's something that that is being worked on for the next major release of Airflow. So having more sort of flexibility around how you can schedule DAGs and what schedules you can create. There are some limitations right now. That's kind of one of the next big pieces that the folks developing Airflow are working on. But yeah, I think right now it's mostly cron. Yeah, just the same cron jobs, or if you're using the built-in Airflow templates for schedules.
Question, are there any caveats or things to watch out for when coupling DAG template dates with data extraction dates? So when you're taking your dates to template in for your DAGs versus the dates itself relative to the data?
Yeah, I mean, I think you would definitely want to, kind of think through how those would compare and be careful when implementing. Again, you always want to avoid like kind of hard coding, quote, like a date within your DAG. But one thing I would say for that is within the Airflow UI, you can look at a templated view of your DAG code that's going to show you. So like anything that you've passed in as a variable or something like that is going to show up there in its actual value. So that's a really good tool to use in terms of if you're trying to make sure that like you've templated things in the right way and that you're passing in the values that you intended to. That's a really easy way to do that.
Gotcha. Yeah. I think that templated view is definitely something I use a lot, right? Because it at least tells you what your DAG is about to do before it goes and schedules that DAG and runs that DAG. Another question in the chat is, when is it a good time to divide a single DAG into separate DAGs?
Yeah, that's a really good question. I think that's a kind of a big, broader question in DAG design, and some of it, depends on, I think it depends a lot on the specific use case. In general, having, one easy one is if you need different schedules for the things within your DAG, it's probably a good idea to split those up, just because, obviously scheduling, like if you're doing something crazy with like branching and sort of conditional paths within your DAG, it could be better to break it up. And if you still have dependencies, you can always, there are a couple of ways to implement dependent DAGs. So having a DAG trigger another DAG or something like that without going into like sub DAGs. So that's one. But I would say in general, like, again, thinking of sort of a DAG as a data pipeline. So if you have, like an ETL case or whatever, having that DAG do that case, not like 5 of them, or, not a piece of one and then triggering another one. That's kind of how I would look at it from a high level. And then, from there, it's obviously use case specific.
So we're gonna do one last question here. Guides and practices around DAG versioning. Have you had to deal with, what are some of the ways to deal with DAG versioning, Kenton?
Yeah, that's a really good question. And I think that's also something sort of more functionality around that is in the roadmap to have that be kind of a native feature of Airflow. I saw Caxel just commented on that, so that's really great. We're really excited about that. In the meantime, you're obviously a little more limited in terms of what you can do right now. One thing I would say is, again, though, using Airflow within the context of CI/CD, and definitely like having your DAGs stored in a repo with version control and stuff, like that's a big kind of low-hanging fruit that's going to allow you to at least have a history of your changes and things like that. Raj, I don't know if you know of any other kind of clever workarounds for that right now before that's more native functionality. I haven't done that myself specifically.
Yeah, I think the version control is the best we can do right now until native support, which should be coming pretty soon. Wow, there's so many good questions. I feel like we could go on all day just answering these, but unfortunately we're right about at time here. This was great. Thanks everyone so much for attending and for all the questions that you've been asking here. Hopefully we'll find a way to kind of answer these as we go here, as we are going to be doing these webinars incrementally and on a regular schedule. But if you want to help with Airflow in any capacity, or you just want to talk about DAGs and data engineering, please feel free to reach out to any of us. Just hop onto our website and fill out a contact form, and we'd be happy to chat just data engineering with you.
Yeah, I'll jump in just kind of to close things off here. Thank you so much for coming, everyone. Kenton and Viraj, you guys did an amazing job. I learned a lot myself, which is great. Yeah, as Viraj mentioned, we'll follow up to everyone on this list with a bunch of information that was asked for in the chat, including the example DAG repo that Kenton walked through. You're able to easily run that locally with the Astronomer CLI, which is just our open source tool for running Airflow locally if you're interested in getting your hands dirty. We'll also follow up with a link to the Apache Airflow Slack. If you're not in there, highly recommend joining. It's where a lot of these questions can get answered and kind of talked about in the Airflow community. So definitely join that if you're not already a part of it. And then finally, what we'll do is we'll follow up with a link to the next webinar as well. We're going to be doing these on a regular cadence going forward. So if you want to take an hour out of your day and just come join and hang out with us and have some fun and talk some Airflow, we're gonna kind of expand our horizons in terms of the topics that we cover over the next couple weeks. So very much looking forward to it, and thanks for coming.
Yeah, thank you, everybody. Great discussion.
Thanks, everyone. All right.